Hey everyone, this is Cyber Defenders, and we have MITRE 1598.002, an easy endpoint forensics lab by Cyber Defenders. Let's read the scenario while the lab initiates. Adversaries may send spearphishing messages with malicious attachments to elicit sensitive information that can be used during targeting. Spearphishing for information is an attempt to trick targets into divulging information, frequent credentials, or other actionable information. Spearphishing for information frequently involves social engineering techniques such as posing as a source with a reason to collect information, for example, establishing accounts or compromising accounts, and sending multiple seemingly urgent messages. All forms of spearphishing are electronically delivered social engineering targeted at a specific individual, company, or industry. In this scenario, adversaries attach a file to the spearphishing email and usually rely upon the recipient populating information and then returning the file. The text of the spearphishing email usually tries to give a plausible reason why the file should be filled in, such as a request for information from a business associate. Adversaries may also use information from previous reconnaissance efforts, for example, searching open websites, domains, or searching victim-owned websites. And they can use this information to craft a persuasive and believable lures. Alright, now that our lab is up and running, let's take a look at the folders in front of us. Inside the challenge folder, there's an Outlook email file waiting for our attention. And if we peek into the tools folder, we'll find two handy tools, CyberChef and Oledump. Let's start with the first question. What plugin is included in Oledump used to scan streams in message files? I started by googling Oledump cheat sheet, and I stumbled upon a helpful cheat sheet from Sans. With a quick search for a message file, because that is the format of the Outlook email we are dealing with, we found our answers. Two plugins popped up that might be useful for our task. The first plugin is called Plugin Message, and the second one is called Plugin Message Summary. Diving deeper, the plugin named Plugin Message identifies Outlook message files, while the plugin named Plugin Message Summary pulls out the header information from those emails. Based on this, our answers to the question is Plugin Message. That is the plugin we need in order to scan the streams of the message files. Question number 2 says, what are the 8-digit hexadecimal codes related to the attached long file name stream? To kick things off, I ran the oledump.py script. This is done using the command python3 oledump.py tag p. Then I provide the argument for the plugin that I want to use, which is plugin_message.py, followed by specifying the path where our Outlook email file is located. Given the large volume of results this produced, it made sense to narrow things down a bit. And to do this, I piped the output to the select string PowerShell commandlet, filtering specifically for the phrase attached long. This is the file name stream we are interested in. This method led us directly to the 8-digit hexadecimal code that we were looking for. So, after formatting the code in the flag format, we are all set to submit and hopefully claim that sweet flag. Question number 3 says, what is the message class? Initially, I wasn't exactly clear on what message class meant in the context of Outlook emails. As always, when in doubt, I turned to our reliable friend, Google. This took me to one of Microsoft's documentation pages, which had a handy list of all possible message classes with accompanying descriptions. Given that our focus is on email messages, I zeroed in on the IPM.note message class. This also seemed to match the format of the flag that we were aiming to find, but never want to jump to conclusions. I wanted to verify. I took another run with Oledump on the email file, but this time with a twist. I specifically filtered for message class. And what do you know? The result was consistent with our earlier finding. The message class was in fact IPM.note. So there it is, our confirmation that we wanted. Now we can submit the flag. Question number 4 says, what is the sender's IP address? Our target is the email headers, as this is typically where we will find IP address information. Now, From the first question in this lab, we recall coming across a sans cheat sheet that mentioned a plugin called Plugin Message Summary. This plugin is designed to extract email header details from a message file. However, when I tried running this plugin on the email file, it only produced a brief overview of the email. And that's not what we are after. We want the detailed email header information. So, to broaden our search, I decided to execute Oledump with the -h command. This helps check if there are any additional options that we could attach to our plugin. And as expected, there is an argument named plugin options. Probing deeper using the -h command again, I discovered another handy option labeled -h. This option lays out the full email header information for us, which is precisely what we have been hunting for. Navigating through email headers, the received lines are very important. They chart the email's journey, marking each mail server it touches on its route to the final recipient. Each server, while handling the message, appends this line to the header. This not only creates a traceable path for the email, but is also crucial for our current purpose. Breaking down the received lines in our email header. It starts with the IP address 68.109.200.102. The email then went through the SMTP12 host, which then forwarded the email to the eCheck12 host. And from there, the email transitioned from eCheck12 to another server simply tagged as CSP2. It then moved from the CSP12 server to a server starting with SP12. And finally, we have the SP12 server dispatching the email to the recipient's mail server. Given this path, our focus should be on the last hop, which, from the recipient's viewpoint, represents the sender's IP, and this IP is 210.134.168.89. Question number 5 says, what total delays in seconds happen between the sender and the email receiver? Email headers, specifically the received lines, come equipped with timestamps. These timestamps denote when an email hits each server in the chain. To determine the total time delay, we start with identifying the timestamp from the first server in the received chain. This timestamp indicates when the email was sent. Next, we locate the timestamp from the last server in the received chain. This represents the time the email was delivered to the recipient. And finally, we subtract the first timestamp from the last to find out the total delay in seconds, which will be 3 seconds. Question number 6 says, what is the company that developed the anti-spam software used by the target? The target's anti-spam software is from elicit, and we know this because there's a header that is called elicit antispam. Question 7. What is the MD5 hash of the zip file included in the attached HTML? When we go back to check the email summary using our usual plugin, we find that there is an HTML attachment with a stream number of 4. To get hold of this HTML content, we use the -s option, followed by the stream number, and then the -d option to dump the stream's content. Once we do that, we see the HTML data show up on the screen. To make it easier to work with, we redirect this data into a file called attachment.html. Now, before diving into the HTML code, we decided to execute the file dynamically just to see what happens. And sure enough, it downloads a zip file, which is precisely what the question is asking about. To find the MD5 hash of this zip file, return to PowerShell. We use the commandlet getFileHash, and then we specify the algorithm by using the dash algorithm option and providing the name of the algorithm that we want, which is MD5. Doing this will spit out the MD5 hash, giving us the flag that we are looking for. Question number 8 says, what full URL is used by the malicious shortcut embedded in the zip file? After downloading the zip file, I realize it's password protected. I thought maybe the email body might have information about the password. To find out, I checked the email summary again and discovered that the email body had a stream number of 38. So I used the -s option followed by this stream number and added the uppercase S option to dump the text strings from that stream. And voila, we got the email body content, which provides the password as ABC123. Armed with the password, I proceeded to unzip the file, and inside, I find a folder containing a shortcut. Sensing that this is likely a malicious shortcut, I decided to investigate its properties by right-clicking on it. After copying the command into Notepad, we see that it includes a URL which is part of the payload, and that URL is the answer to the question about the full URL used by the malicious shortcut. And by this, we have reached the end of our lab. So, thanks for watching.